Morning. We're just a minute here, so we'll get started. We'll start with a little bit of the introduction about our company, and then we'll kind of move into the agenda and the content. So to start, welcome. This is Walter Petrus. I'm the Senior Vice President for Modern Apps and Data Analytics. This is our 6th webinar. We're very excited to talk about data analytics and certainly Fabric. We've got a few people joining from the Fabric conference. So for today, I'll go through the agenda. We'll go through a little bit of the NetWoven introduction and give you a little background about our company. You know, we're obviously here to talk about data science. Many of you are probably advocates of using data science in your company, but we want to kind of highlight some of the areas we're seeing in the last few years of using that in business decision making. We'll go a little bit deeper into the data science workloads and the ML journey and kind of give you a little bit of background of some of the tools that we're going to talk about today. And then finally, we're excited to share how Fabric really makes that data science work a little easier. We have 2 hands-on demos that we'll go through, so we'll spend the bulk of the time going through those, the use case and then the solution demos. And then we're fortunate to get a presenter from Microsoft talk a little bit about Fabric Capacity. A lot of you are asking that. It came up at the conference. And then we'll have some time for the expert Q&A panel. Thanks. Next slide. Really encourage everybody, please take the time to ask questions. We'll try to do our best to answer them throughout the presentation because there's a lot of different topics we'll cover. So please just click the Q&A. We'll catch that. We'll try to highlight that so the presenters know about the questions as we go through it. A little bit of background about NetWoven. We've been here about over 20 years in business. We have offices here in the United States. We have people in every time zone working with many of our customers. But we also have a big team in India, 2 major centers that we have in Kolkata and Bangalore. I've got folks here from that organization. We're certified in all 6 of the solution areas that Microsoft offers for cloud partners. We're part of the MISA group because one of our products is highly secure, a security-focused product. So we're very fortunate to work with Microsoft, and we've got, you'll see some speakers today from Microsoft. Next slide. Although I manage the modern apps and data analytics practice, we've got a broad team that are working with some of the largest companies in the world. Some of the focus you'll hear crosses some of the different topics. Some of the topics we'll cover will cross some of our practices. Today, we're really focusing on data analytics, but we're pretty excited about this accelerated computing and AI team. Again, some of the components that Pankaj and the rest of the team will talk about come from that team. In a few weeks, you'll see a Purview security and data governance presentation and a webinar, and that's going to be another thing that's happening with the security team and our data analytics group. And then finally, there's some Copilot briefings that we just did, and that's where we did that with the Content Collab and Cloud Infrastructure team. So we all try to work as one organization, but we've got specialties and depth in each of those areas. Next slide. As I mentioned, I manage the data analytics team. We're fortunate to be, I've got a few of the folks here representing that team. We cover a lot of different areas from advanced analytics, helping people move from warehouse to lakehouse. We've had a couple webinars, and there's some great ebooks available on our website. So please take the time, take a look at our website, and you'll see those ebooks available to cover some of the topics. Today, we're going to really drill down a little bit more on the Gen AI and predictive analytics. Next slide. As I mentioned, we've got quite a few folks from our team presenting. Fortunate to have Pankaj and Alok from our engineering team. Anya is going to join us is here from Microsoft, talk a little bit about the Fabric planning. And then from the conference, we've got Nana and Raj that can also talk a little bit about some of the latest announcements and pretty exciting. We heard that 11,000 customers are paying customers on Fabric already, just after a quick 2-month introduction here. So pretty exciting news and looking forward to that continued success of the Fabric platform. With that, I'm going to turn it over to turn it over to Pankaj, talk a little bit about data science. Thanks.
Hello, everyone. Welcome again to our webinar on data science and with Fabric. We probably can say with confidence that data is the driving force behind innovations and decision making of every business today, right? So in today's session, we'll explore the basics of data science and how you can leverage the transformative power of data science easily to the most comprehensive analytical platform exists today, and that is Microsoft Fabric. Now, for the past few years, globally, we see the data volume is growing exponentially. right? While this is great that we are producing data from all of our activities and touch points, the challenge is how to consume and make sense of this huge volume of data. In the absence of appropriate technology, a great percentage of this data remains completely untapped. And that is called the dark data. And the percentage varies anywhere between 60 to 85%. However, the recent advancement in data science is changing that scenario. Machine learning models are now accept more and more data. Higher the data volume, better is the outcome. From personalized recommendations to predictive analytics to generative AI, businesses are harnessing the power of data science to gain valuable insights, optimize operations, and stay ahead in the competition. So let's talk about the definition of data science a little bit. So there are many definitions that float around, but the one that is here is probably get the best essence out of it. So data science is the process of creating software from data by extracting insights, patterns, and knowledge from data sets. Previously, software used to create data. Now we are creating software out of data. And to make that happen, we need to go through the process of data engineering, where we can collect, clean, extract, and transform the data. Then we go through the analytics phase to understand the insight. And finally, we use the data science to build the model, which is nothing but software, to predict and forecast our future. So let's take a look how data science is reshaping the business strategies, turning uncertainty into opportunity with insight. So start with data-driven decision making. So make decisions based on the facts and evidence rather than intuitions or guesswork. Analyzing large volume of data, businesses can identify trends and patterns, which typically is not available when you're looking at the smaller scale. This information can then be used to make more informed decisions about product development, marketing, and other areas of the business that improve efficiency and productivity. The predictive models can forecast demands, identify potential problems, and optimize supply chains. And this can lead to significant cost savings and improved operational efficiencies. Better customer understanding. So by analyzing the customer data, such as their purchase history, their demographics, their social media behavior, we can plan better targeted marketing strategies and improve customer services, the product and services that meet their specific needs. New product and service development, identify the new product and market opportunity by analyzing the customer data for any gaps that exist or there is a surge in demand for a sector. Predictive models can take that as an input and suggest the scope for new product and services. While you have all of that, then you automatically gain competitive advantage by making better decisions, improve efficiency, and productivity. So some of the market survey here I'm projecting like what they have to say about the impact of the data science. We're looking at global market for predictive maintenance that is forecasted to reach 19.3 billion by 2028. 80% of the companies report that they have already invested in machine learning and they're getting a benefit out of it. Okay, conversational AI, which is so popular nowadays, will reduce the contact center labor cost by $80 billion by 2025. But ironically, like when the last survey done, like July 2023, only 20% of the major corporate leaders, they said like they have used ML. So there's a huge opportunity that lies ahead for us. Okay, now let's take a look at some of the use cases which some of our customers from different sectors they are getting benefit out of this data science, though early phase, but there's significant impact they're already experiencing, and there's a huge potential lies there. For retail, it is demand forecasting and customer segmentations, very bright areas in both the sectors. Healthcare, it is predictive analytics for patient optimization, patient-like outcomes. So the providers can leverage the patient data, electronic health records, and medical imaging to develop the predictive models for diagnosing the diseases, assessing treatment effectiveness, and forecasting patient outcomes. And we'll see an example of that in today's demo. In manufacturing, predictive maintenance is a huge opportunity. Manufacturers can use the sensor data and machine learning algorithms to predict equipment failures before they actually occur, and preventing untapped downtime, optimize maintenance schedules, and extend the equipment lifespan. Coming to, say, finance, right? Risk modeling has been in use for a while now, but by leveraging the predictive risk modeling and analytics, financial institutions can better manage the risk exposure, optimize capital allocations, and comply with the regulatory compliances. Algorithmic trading, this is a very interesting area. Like, people are already getting benefits out of that, like, machine learning models predicting the stock movement and with reasonable accuracy. Okay. In transportation and logistics, route optimization is a big area. The transporters are already making use of it. They're saving on fuel consumption, reducing transportation cost, and so on. Okay. So coming to, when we looked at some of the applications of the data science, we need to understand, like, what are the modeling techniques that are in relevance today. Okay. So starting with regression analysis, there are several factors that can influence an outcome. In pretty much every cases, that is the case. So in this approach, what you do is we find the impact of one factor on another. And this technique is used in, like, sales forecasting and customer lifetime value predictions and so on. Classification model, in this case, like, we use to categorize data into predefined classes or categories. And the examples of this model where it is used is credit risk assessment, customer churn predictions, and so on. Next come to the clustering model. So here we group the similar data points together based on their characteristics. And we use this model typically for, customer segmentations, product recommendations, and so on. Then time series forecasting, this is used to predict future values based on the past observation of time ordered data. And this is used for demand forecasting, stock price predictions, and so on. Then recommendation system, this one is probably we are most familiar. We typically get recommendations all the time from YouTube or Amazon and whatnot. This takes the behavior of the customer and their context to predict that the item predictions. Then comes the anomaly detections. It is used to identify unusual patterns or outliers in data that deviates from the normal behavior, and they use effectively for fraud detections, equipment failure predictions, and so on. And then comes the natural language processing. This is very common. We typically use it for contract processing. We use resume screening. Like, these are the big areas. And right now that all the LLMs are actually based on this model. Okay, it's a hugely popular and very significant the modeling technique. So now understand, like, what are the frameworks that are available today for machine learning. It start with the scikit-learn. This is the oldest one and very popular one. It has a very powerful Python libraries. It has a wide range of algorithms, so you can try out different modeling techniques. It has, like, solid integrations with many Python libraries, and there are powerful tools available for starting with your model experimentations, the selection of model, the feature extractions, and whatnot. So very rich library. Next comes that deep learning. And this is at the core of, like, this huge surge in the text generation models like LLM. Traditionally, this used to be used for, like, image analysis and face recognitions and so on. So a new variant, I would say, of this model, which is called transformer model, is now in use for this, text generations. And finally, the Synapse ML, this is the latest one, and this is a highly scalable machine learning pipeline. This is built on top of that Apache Spark distribution computing framework. It is built in Microsoft Fabric, and it provides the native connectivity to Azure OpenAI. Okay, So having understood the basics, let's understand like how the process of data science, or in very specifically how the machine learning model creation and publishing works. Okay, we start with what is our objective and what we are trying to achieve. This, we need to be very clear on that. We need absolutely clarity in our expectations. We then access our historical data, run analysis to discover the data, its features, distributions, correlations, etc., and then take appropriate actions to cleanse, enrich, and remove biases, etc., to prepare data for the modeling. Next activity is the experiment. We start with a base model and the base range of parameters and hyperparameters. We run through a process of fine tuning of parameters and hyperparameters. And this is the iterative process. Okay. And every time we run an experiment, we test that experiment against that the data that is available and see how good fit the model is and the experiment is. And this process continues till we find the best experiment. And once this best experiment is found, we save that as a model. Okay, and that model is published and stored in a model registry. And from that, this model can be used for an unseen data set, okay, to predict their outcomes. Okay, so this is how it works in general. Now, let's take a look how Fabric data science workloads are supporting this process end to end. Okay, so starting with, we have OneLake, where all kinds of data is ingested and stored in open common format, that is Parquet. And then we have that workspace. So in the workspace, we have all sort of tools that is available to do your ETL on your data for preparing and cleansing your data before you pass it on for modeling. Now, once the data is ready, you have the notebooks where you can run your data discovery. You get the insight, you understand like what this data is for and what kind of model will be suitable for getting the outcomes from this data. Once you do that, you run the experiment. Again, you run that with the notebook. And to facilitate your experiment, we have the ML flow completely integrated with the Fabric now. So you have experiment center, you have that model management studio, and all coming from the ML flow, and which is completely, the moment you run that experiment, all of that experiment gets tracked and monitored and logged in the experiment center. You go there and visually, without writing a single line of code, you can go there and compare your experiments and decide like which model is the best model by comparing their different matrices, and then save that experiment as a model. That all is available within this ML flow environment and integrated with data science workload of the Fabric. And once you have that model, you save it to the model registry. And from that, you are ready to try it on unseen data set. And for that, you have the batch predict feature available, again, integrated with the Fabric. Okay, and the outcome of that, the predictions, you can store back into your OneLake. And from there, what you can do is you can access that data for visualizations and any further analysis using the Power BI. And for that, you have the direct lake connectivity for almost real-time access of your predictions data. Okay, so some of the advantage we can call about the Fabric, right? So it's the data centric. So the OneLake, as I said, like it has all kinds of data that can get ingested into the OneLake and get stored in a open format called Parquet. And the great ingestion tools, you have hundreds of connectors that are available. practically from any kind of data source that you can think of today and get your data into your lakehouse. And after that, like you can perform any kind of ATL operations using the data engineering, all the data engineering workloads that you have at your disposal. So once you do that, you have that rich machine learning tools that are available, whether it's a ML flow, experiment and model, whether and going forward, you have like Synapse ML as well, that capability. So that is a very scalable, completely production ready, like the pipeline that is available. Okay, and then you using the Synapse ML, you can make a direct connectivity to your Azure OpenAI so that you can take advantage of your generative AI, requirement as well. Okay, and then you have the direct led connections to Power BI so that like your predictions are readily available to your the visualizations and reports. It is extremely developer friendly, right? It's a SaaS experience. So you just open up your Data Science Studio and that's it. All the tools are available right there. And if you're not so familiar with Python and if you have access to Copilot, all that you need is put your idea what you're going to do, and the Copilot will suggest what Python code to write, and you will end up with elegant codes to run your machine learning experiments. Okay, and if you are familiar with, very comfortable with the Visual Studio or running on your desktop, you have the Visual Studio integration right there, right? So you don't have to, you can basically run your machine learning experience right from your desktop. Okay, and collaboration, it does facilitate collaboration because everything is together, and you can collaborate with your other persona in your organizations, data engineer, analyst, and whatnot, and completely secure collaboration on your data, code, and the models. Okay, great advantage, everything in one platform. And one of the biggest advantages that like machine learning, one of the difficult point of the machine learning experiment is running a test and pilot is easy, but productionize your machine learning model is extremely difficult. Most like 90% of that some statistics say 90% of the machine learning models doesn't see the production because of that. The Fabric streamline all of that. Okay, so we'll look into more during our demo sessions. Okay, so with that, we arrive our demo, and we will be talking with our the use case for the healthcare demo. So this is actually predicting that a heart rate, so heart attack predictions. Okay, the cardiovascular diseases are the major cause of like premature deaths globally, and staggering 17.9 million people. It takes the lives every year, right? So one of our healthcare provider as a customer wanted to create a machine learning model to predict the risk of heart diseases among its currently registered patients. And for that, it used its historical patient database. The data set has 11 features that are somehow correlated with the heart diseases. Okay, and the experiment that we do or will follow in this particular case, all within the Fabric. So for that, first we will ingest the data. So we have data pipelines or data flow Gen 2, or we can also upload the files. There are many options, right? So we get the data into the lakehouse in the raw format. And after that, we do the preparation, cleansing, and all this stuff. Whatever ATL we have to do, we can use the notebook, or we can also use that, the like Dataflow Gen 2 or pipelines also there. And then we have the clean data, which is typically available and kept into another lake house. And from there, we start our discovery process. And for that, we use the notebook and use all kind of, typically it's a Python and all kinds of statistical modeling techniques that we use to discover the data. And then we go for the data preparations, again, with the help of notebook. And finally, we come to the model identification step. So the model identification depends on like your outcome from the discovery. You understand like what is the data set and what the outcome expected. Based on that, you select your model, and then you go into experimentation. So in the experimentation, you typically you split your data between test and train, and then you iteratively experiment on your data, and finally you arrive at the best model. Okay, and once the model is once you find your best model, we use that for predicting on your unseen data sets. So that is the process, and for this entire operations, it happens within the ML flow environment that is integrated with the Fabric data science workloads. Okay, so with that, we will jump onto the demo, and for that, I will invite Alok. Alok.
Thanks, Pankaj. Let me share my screen. Okay, welcome everyone. As Pankaj has stated, we would be using historical clinical data of patients, some of whom have been suffering from heart disease, to predict heart disease in patients. For this, we have received clinical data as CSV files, and we have stored them in a Fabric workspace under a lakehouse. Now, for processing of data, we would be using Python. For that, we have created a notebook in the same workspace that we would use to write Python code and execute it. To start with, we have read data from CSV file, and then we have a sample of data here. We see all 11 features from data here: age, sex, chest pain, etc. And the target, the column that we want to predict. Okay. Now, we will start by exploration of data, and we first use different methods available for us from data set. For example, understanding the types of data, availability of null values, duplicates present in the data, as well as statistical methods. For example, count, mean, standard deviation, spread of the data, etc. Along with that, we would be reviewing the trends present in the data using visual methods like charts. Let us take a look at some of the charts that we have created. This is a combined histogram of all the features present in the data set. And to start with, we have age, which seems like near normal with some peaks in between, some spikes in between, and which seems to be well-rounded data. In case of patient 6, we see that number of male patients in the study is much larger than female patients. Similarly, we see in case of chest pain, most chest pains are quantified under asymptotic chest pains. Apart from trends, we can also see aberrations in the data. For example, in case of cholesterol, we see that one of the values, 0, has more than 150 patients, which seems like a odd value. It may be an issue with the data. Next, look at this data. This is a plot between chest pain type and heart disease. As we see in these charts, we see that in case of patients without heart disease, as expected, we see that most of chest pains are atypical or non-anginal pain, whereas unexpectedly in case of patients with heart disease, we see the asymptotic chest pain is a major chest pain type, which is kind of silent heart attack. In the third case, we see that we have plot between patient 6 and heart disease, and we see here that the most of the patients, or that this plot is skewed for male members. So number of male patients having heart disease is larger than female patients. Now, once we have explored the data, we will now move to select data or the features that we will use for creation of machine learning models. For this, we will use correlation matrix. Now, this matrix identifies dependency between the different parameters, and it can have value from -1 to 1, where -1 is strong inverse proportionality and 1 is strong direct proportionality, where 0 means no dependency at all. Here we can see that most of the values are less than 0.5, which indicate that any single parameter does not dictate heart disease. In other words, all of these parameters have some impact on predicting heart disease. So at least for this demo, we are retaining all of these parameters for learning for our machine learning models. Now, once we have decided which features will be there, we will proceed to create data set for machine learning model. Here we will separate our parameters from our target, And hence we removed heart disease from the main data frame and create a separate data frame for heart disease. Next, we will convert our string values or categorical value into numerical values. As machine learning models cannot learn from string values, they need numerical values. Finally, we divide our dataset into training and test datasets. So we divide the same dataset in a proportion of 70% to 30%, 70% for training, and 30% of data will be used for testing the model created. Now, at this point, our data is ready, and now we are ready to create model. But which model should we use? Now, we do not know which model will work best for our data set. Hence, we have taken 3 different candidate models, Tender Forest classifier, Gaussian regression, and XGB classifier. And with them, we have created an experiment in the Microsoft Fabric workspace itself, using MLflow and Scikit library. And so this particular piece creates the experiment as well as different models, which are also stored in workspace. Okay. Once all of these three models have been created, we are ready with our models. Now we need to decide which model works best for our data set. So we'll move to experiment now. Now this is an experiment that we have created, and we can see there are 3 run instances for each one of our models. Let us compare these run instances. We select all 3 run instances, and we see in terms of performance, training accuracy, and training F1 score, we see that the model Brave Pencil instance works best. Okay. Now, at this point, at least for this demo, we can say that this model works best. And now we are ready to share this model with a larger organization. Hence, we will go ahead and save this model for rest of the organization. So we'll select this model and we'll save it, ideally in a separate workspace that is shared with rest of the organization. We can create a new ML model, that we will do for the first time. But for the next time onwards, we will use an existing model, because when we save an existing model, we create a new version of the model. Okay. And by having multiple versions of the model, we are able to compare models as more and more data is used to train the model itself. Now we see that these are the 3 models that we created during the experiment, and this is the one that we created after we selected a particular model for our inferences. Let us go to this particular model. Now we see that we have 2 versions, and we can use either versions to make inferences. Let's use a version 2 for making inference. For this, we'll take some data that needs to be predicted for, which is present in a delta table itself, in a delta table in the lakehouse. We select the data. We provide the mapping if column names are different. We provide the name of the table, the way data needs to be stored. And then finally, we give the name of the column where predictions will be stored in the table. When we do now at this point, it gives us an option to create a new notebook to run this code, or we can copy this code and run from an existing notebook. Okay. Once we run the code, it downloads the model, and it executes the model against the table, against our data, and then creates prediction and stores the predictions in delta table. Now, when we look at the prediction table, we have this table has been created, which has all the parameters along with the final column, which has prediction for that particular record. Now, this is our final data product that can be used for reporting and other purposes. This is all from my side. Thanks a lot. I hand over to Pankaj.
Thank you, Alok. And just to add to what Alok already said, like, as of now, if you have to predict from the model, then you have to use that notebook route. But very soon, like the model will be available as part of the machine learning, that the pipeline flow activity. So you don't have to go through this code anymore. So you can, from a pipeline activity, you can hook onto a model and you can run your predictions. So that is coming very soon. Okay. So having said that, So let's go to our second part of our demo. And this is on a retail sector. It's one of our customers that from the retail sector basically runs a superstore chain. And they want a sales forecasting model to predict sales volume for upcoming 6 months. That way they can better manage their inventories and optimize the cost. Okay. And the way that this model experiment is run is pretty much the same as what Alok demonstrated. So the only difference is like we have to run a hyperparameter fine-tuning process, which is mandatory for a time series data. So we'll look into it as we go into the demo. So let me switch over to the demo. Okay, so just like what Alok did, so we have uploaded a sales data set over here, and this is my lakehouse, and the data actually uploaded to one of the Delta table. Okay, the Superstore data, and as you can see, this is pretty regular, like the sales data set, as you can expect, like all the features like order, ship date, the customers, like the locations and the product ID, category, subcategory, and so on. All the dimensions are there, and along with that, there are some facts like sales, quantity, discount, profit, etc. This is there. So, so what we do now, we are ready to run the experiment with this data. Okay, so the first thing first, like we need to do some housekeeping jobs and importing some of the models that necessary for running the machine, like running this experiment. And one of the first things that we do using Notebook is load the data into data frame. And the data frame of our choice, in this case, is the Pandas. They provide excellent analytical capabilities. And I'm pretty sure like many of you probably are familiar with the Pandas qualities. So that's what we're using the Pandas for. So one of the first things that we're doing is cleaning the data set to some extent and giving access to our business users and data analysts so that they can also take a look at the raw data sets and run their kind of insights. So with that, they probably can run a report like that directly from that data sets, and they can do their bit of analysis at their end. Okay, so coming back to our experiment. So the first thing that we have to do, if you remember, like we have to do the data discovery to understand like what kind of data set we have. So again, we use the Panda capabilities over here and try to look at like what this data set is all about. Okay, so here we see there are 3 major categories of products. One is office supplies, technology, and furniture. Office supplies, by the number of orders, they get the absolutely larger volume, 60% and above. But in terms of like sales amount, if we consider, that is pretty evenly distributed. And while looking into the total quantity sold, again, office supplies is 60% plus. However, if you look at the contribution for profit towards profit, technology is leading the pack. Okay, so it's the high level understanding. Let's get into some more deeper insight into the data. So we are looking into, again, using the Pandas like analytical capabilities, we look into monthly percentage profit by category. So here we see like, the furnitures are providing the least profit margin month to month, and technology is the highest, providing the highest profit margin. Okay, so some other dimensions. So let's take a look at like how the discount impacts the overall sales volume. So contrary to many of our popular belief, like higher the discounts does not translate into higher sales. Okay, so as you see, like even at 60 to 70% discounts, the sales volume is pretty minimal. Okay, so now that we have good understanding of the data, let's try to do some preparation for the modeling. And in our case, our objective is to forecast the overall sales for a specific product category. And in this case, it is the office supplies. So what we do is we filter out all other data except that belongs to office supply as a category. Okay, and then one more thing that we have to do, because we are running a predictions on time series data. So all that matters is the timeline versus the sales volume coming from that office supplies. So all other features are insignificant at this point of time. So we'll drop out everything else from this data set. So we end up with a data set which is only the timeline and the office supplies sales. Okay, then one more thing we have to do, the sales data that we have is on the daily basis, and our unit of measurement is month. So what you have to do, we have to resample the data for the month. And then when you do that, we see that these are the kind of fluctuations of the sales volume month to month, starting from the January 2020 all the way to kind of August, September of 2023. Okay, so now we are ready to extract some features out of this data, and for that we'll be using the stat model. Okay, so what we do, uh, first, even before we do that, so what you do, one more item that we need to do is, like, we need to split the data set between test and train. So 80% is the train and 20% is the test data. So 80% data will be used to train the model and 20% for the testing the model. So now come to the feature extractions. So for any time series data, typically we have 4 different elements that is hidden inside their time series data. One is called level, which is the data that you get to see. Then there is a trend, like whether there is any kind of trend, upswing or downswing exists in the data set. Then seasonality, whether it is any seasonal fluctuations in the data sets. And then there is the noise. There is a noise that these are fluctuations that we cannot really explain readily. Okay, so using the stat model, we can extract those features from this the time series. So here you can see the same data when you extracted for different features. This is how the seasonality looks like, and as you can see, there is pretty fairly seasonal, fairly regular pattern. And the trend, you see the slightly upward trends in the sales volume. And the residual, this is the data that we do not have ready explanations. And then this is the overall the data looks like, how it looks like. Okay, now so we are using stats model, as you said, and within that we are using an algorithm which is called SARIMAX. The SARIMAX stands for seasonal autoregressive integrated moving average with exogenous regressor. Pretty heavy term, but this is one of the best model for time series data and predictions. Okay, so the first thing that we'll do when you are ready for that model experiment is that hyperparameter tuning. So what I mentioned earlier, right? So what you do is, like, we pick up like 2 sets of parameters. One is regular, one is seasonal, and assign them random numbers within a range. Okay, so we don't know what parameters will work best for our model. So we assign the random numbers within range. And then what we do is we run the experiment, and in that experiment we basically iteratively assign that parameters from the values from within that range. And every time we assign the parameter value, we check how the model is doing against the expected results, right? And that way we get the results and check some of the metrics. So one of the metrics called AIC, and if that is the lowest, that gives the best model of the lot, best experiment of the lot. So we run that for iteratively in a loop, and at the end of it, we end up with a lot of experiments. So this experiment is running, and all of these experiments are available in the experiment center, which Alok demonstrated earlier. So if we go to the experiment center, they all are available. But for now, from the code also, we find out what is the best model over here. And this is the AIC with the lowest number and correspondingly parameters, parameter values. Now we get our best experiment, but is this really the best? For that, what we have to do, we have to do some experimentations with this, with the test, basically with the best experiment that we have found so far. So we do some forecasting. Okay, so once we run the forecasting, so we get like the predictions. Okay, so we get the predictions and then we validate the predictions. So the orange line over here is actually the predictions and blue is the actual. Now we validate the predictions, and once we are confident, like, yeah, this is the best experiment we have, we save it as a model. Okay, so once the model is saved, then what we do is we run our like unseen test data, unseen like run the model for unseen timeline, unseen time frame. So we have decided a time frame which is like 6 months, in the past and 6 months into the future, so that we have the opportunity kind of to see how the model is performing against the actual, and then the prediction, of course. Okay, so we run that predictions, we get the predictions value, and we finally save it to a table, so that like delta table, so that like we can visualize the data in a visual format, and we obviously run that Power BI model from that table, and this is how we see our like the model performance. So this is the blue line, the light blue line, this is the actuals, and the dark blue line, this is actually the predictions. And you see the overlapping zone for a few months, and you see that though the values are not exactly matching with the actuals, but the patterns is pretty well followed. And this is how the predictions looks like. Like I know, like we have to really rush through it for the crunch of time, but there are a lot of information that we need to be communicated. And if you have any questions or you need any clarity, please get back to us, and we'll be happy to answer as best as you can. Okay, with that,
Thanks.
I'll hand it over to Ananya. We have a very interesting topic coming up, which is called fabric capacity planning. Over to you,
We can bring the
Ananya.
slides up. But thanks, Pankaj. Again, please post any questions. Happy to try to answer them as we're going through there. And I'll turn it over to Ananya. Please jump on in.
Yes, thank you so much, Walt and Pankaj. Yeah, if you can quickly go to the slides. Yes. So one of the things that we will be talking about is fabric capacity planning, right? Um, okay. So when migrating from Azure Synapse Analytics dedicated SQL pool to Microsoft Fabric, one of the very common questions we get is how do we plan for capacity, right? So it's very important to consider the mapping of data warehouse units, DWU, in Synapse dedicated pool to Fabric capacity units, which is often called as CU. But it's not a one-to-one mapping, and it's not a simple resource mapping. Like there's so many things into consideration, like CPU, memory, input, output between Synapse dedicated SQL pool and also Fabric. So it's not a accurate, one-on-one comparison, because there are many differences as well between the two products. And then the major differences, between the two products is being the query optimizer, data storage, workload management, burstable capacity, which basically means like, there's a bursting and smoothing process. So when you go over your dedicated capacity, the capacity will burst it out. And again, when your workloads are a little low, it'll like smooth it out. And also the underlying architecture, the underlying hardware architecture is very different for the two products. So so it's not as easy a comparison in terms of mapping. So what we have to do in that case is we do conduct several tests using TPCH data sets, which basically means like different terabytes of data sets, different volumes of data sets, like be it 100 GB or a 1 terabyte or a 10 terabyte. And depending upon the workload sizes, we would decide what should be the starting point of your POC or your pilot implementations. Also, Fabric offers different SKUs based on price and database sizes. The lowest SKU available for Fabric is a F2 and is suitable for development environment and all of that. So that's a very good comparison out there. And in the capacity based model, which Fabric is a part of, Fabric data warehousing kind of aims to make the most of the purchased capacity and also provides visibility into usage. And in simple terms, if you have to do the comparison, one Fabric capacity unit is equivalent to 0.5 data warehouse vCores. So for example, if you have a Fabric capacity SKU F64, it has 64 capacity units, which means that it has 32 warehouse vCores. And there's also a Microsoft Fabric Capacity Metrics app, so that provides you visibility into the different capacity usage for all the Fabric workloads in one workplace, at one place. So administrators can log in and see, what are the different capacity that's being used. And the operational categories are available in three different categories. One is the warehouse query, the SQL Analytics endpoint query, and also the one-lake compute. So across these three categories, you can see, what's your utilization and plan for your future utilizations. Yep, if you can go to the next slide, please. Yep. So now
The one or the next one?
The previous one. Yes, thank you so much.
Okay.
Yes. So now in terms of the Synapse DWU to Fabric SKU mapping, so this chart here shows the mapping by price. So let's start with a simple data warehouse to Fabric SKU mapping based on price. So you can see this information to understand the cost difference of Fabric compared to Azure Synapse. The table here shows the mapping between dedicated SQL pool DWU to Fabric SKU based on on-demand monthly price for the US East region. Of course, if you change regions, this chart might look a little different, but then the underlying, ratios are the same. And also a very important feature of Microsoft Fabric is that it lets you pause and resume your capacity. So when your capacity isn't operational, like for example, maybe think of weekends when you do not have a lot of production workloads and everything running on, you can pause your capacity to enable some cost savings for your organization. And later again, when you want to start your work, like maybe Monday morning, you can resume, your work and reactivate your capacity back. And when you pause your capacity, the remaining cumulative kind of averages and smoothes the operation of your capacity. Now, also another point to note about here is the Fabric Data Warehouse offers a flexible pricing model that allows you to choose the SKUs that best fits your needs, your use case, and also your budget. So kind of the F2 and the F4 SKUs are the lower cost options, but they do not have an equivalent Azure Synapse dedicated SQL pools, which means that if you're in Fabric, you have more options for cost efficient data warehousing solutions. And you can see for F2 and for F4, the price for data warehouse is $262 for F2 and $525 for the F4 SKU. Now, one of the key cost saving factors of Fabric is its capacity reservation discount. So if you reserve your capacity for 1 year, you can get a 41% discount on the pricing. And this is slightly higher than the 37% discount that was originally there for Synapse for a 1-year reservation. So essentially, Fabric is a little cheaper if you're going the route of a reserved instance. Again, I kind of touched upon the reserve and the pause and reserve. The pause and resume your capacity feature in here. So this can lead to significant cost savings, especially for businesses that do not require, like 24/7 access to your data warehouse. Again, depending upon your region and other factors, your prices might vary a little bit, but you always have to keep one thing in mind, that the best SKU for your workloads depends on the specific use case you have, your requirement. So it's always, go through the testing mechanism. So you should definitely do a testing depending upon your workloads and see what works for you. Next slide, please. Now, in terms of the development environment, we often get questions like, when we are choosing our development environment, what SKU should we start with? So the F2 SKU, which I pointed out in our previous slide, so the F2 SKU in Fabric Data Warehouse is a very cost-effective option, especially for development environments. Now, the starting price of this is just $0.36 per hour, and it kind of provides a balance of performance and cost as well. And for non-production environment, this is a great option to start with. Because your non-production environments will often have development and function testing and all of those features, right? So and that is like typically they would typically use a subset of the production data and would not have require any stringent performance level service agreements, all of that. So that makes the F2 SKU a very suitable option for these environments. Another key feature of the F2 SKU is its ability to assign multiple workspaces to a single F2 capacity, which basically means that it can allow multiple development teams to share the same capacity. Like if you have a data science team, if you have a data engineering team, you will all share the same capacity, the same F2 capacity, while still maintaining workspace and resource isolation. Like you would be able to work on your own workspace, on your own resource, but still share the same same capacity. So this leads to significant cost savings and also reduces the need for each team to have their own dedicated capacity. You can also upscale instantly with no downtime as additional workloads are loaded. Like when you get more data, you can upscale immediately. So you can easily convert the workspace from a dev environment to a test environment, or also simulate production, production test cases once you're done doing your development work. And again, if you want to scale down back, when your testing is done, you can scale down back and reserve cost on that, kind of save cost on that. So long story short, the F2 SKU offers a very flexible, cost-effective, and scalable solution for for development environments and also testing environments in the Fabric Data Warehouse. Next slide, please. Yes. Now talking about the mapping on the Azure Synapse DW to Fabric SKU based on the database size. So you have to choose between, what is your data volume. Like for example, 100 GB for a database of this size of 100 GB, the minimum and the recommended SKU is F2. So minimum, and when I say minimum SKUs, that is the minimum that you should absolutely look for, and recommended is, so if you take that SKU, you'll get better performance in terms of cost and operational excellency. For 1 TB, the minimum SKU is F2, but the recommended is F32 because the F32 SKU provides more capacity and kind of is better suited to handle large volume of data, and also potentially more complex queries as you have additional data with your 1 terabyte database. For a 10 terabyte database, the minimum SKU is F64, but the recommended is F28 because the F28 provides even more capacity and is designed to handle the demands of a 10 terabyte data set. So these are just the guidelines. So please choose the best SKU for your needs, and it will definitely depend on a variety of factors here, right? Including the nature of your workload, complexity of your queries, and your performance requirements. So it's always a good idea to conduct some testing and determine the most suitable SKU for your specific use case. Next slide, please. Right. So now this is kind of an addition and continuation to our previous slide. So if you deep dive into the rationale behind the recommendation of each data size, right? So for a 100 GB terabyte data, the F2 SKU in Fabric is capable of handling a workload consisting of a 100 GB data set. And it provides excellent data ingestion, transformation, and query optimization for both Power Run and concurrency. This performance also matches the performance of a dedicated SQL pool of a DW 500 performance. So, but you're getting it at a significantly lower cost, as you saw in the cost metrics that we have. So, for databases of this size, F2 is definitely recommended. But for a 1 terabyte data set, the minimum Fabric capacity that we require is an F2 SKU. The Power Run performance that we see on a Fabric F2 is kind of equivalent to running a SQL dedicated pool of DW 400. So, however, there's a concurrency requirement of faster query performance needed for this amount of data. You might need to scale up, and this is not because the capacity cannot execute the queries, but but because if you have so much of data, you might require running 5 concurrent queries together for 5 concurrent users. So it might exhaust the small F2's allocated capacity, and hence in this case, the recommended capacity is F32. Next slide. Yeah. Now for a 10 terabyte, the minimum Fabric capacity is F64. The Power Run on a Fabric F64 kind of provides the performance comparable to a DW 3000, but at an approximately 1/3 of the cost. So while the 10 terabyte data set can be run successfully on Fabric's F64, you might need to scale up for better performance when running concurrent users, or when you have more workloads, or if you need faster processing speed. And hence, for optimal performance for databases of this size, we recommend a size of F128. That's about this slide. Can you go to the next slide, please? Thank you. Now, the value proposition of Fabric's lowest SKU F2 is quite significant, right? So for the price of a cup of coffee a day, it delivers a complete analytics platform. It can serve as your development environment for one or more workspaces with the benefit of workspace, resource, and security allocation. So I would say that the trial capacity of Fabric F64 definitely offers a great opportunity to experience Fabric at a scale scale and for free. So it allows you to access all the Fabric product experiences for 60 days, including data engineering with Spark, building data factory pipelines, using Power BI's new direct lake mode, and also running a 10 terabyte workload using the data warehouse. So this is an excellent SKU to start with to run a POC or a pilot, and for a competitive performance analysis for datasets up to 10 terabyte. So those are kind of the cost saving options with Fabric. And if you go to the next slide, please. I think this was the last slide that we had. Yes, I kind of already touched upon, what's the value proposition of Fabric's lowest SKU F2. So it is definitely available for free for 60 days, and you can do all of your data engineering, data pipelines, data factory, and your also Power BI's direct lake mode. So feel free to give it a try. If you have a data load of 10 terabyte or less, this should be your most go-to option for running any POC or pilot. Thank you so much. Thank you so much for your time today. And yeah, very excited to be here. And any questions that you might have, happy to answer those.
Thanks. I'm going to put some of them in there, but great job in covering it, all the options there. Just going back real quick, just to recap, I think we have a couple of things that we can help offer in terms of free briefings, and you'll see that as a follow-up mail from some of our sales team, but also the upcoming webinars. This is a great opportunity to learn a little bit more about copilots and generative AI from our new practice that we have. That'll be coming up on April 18th, 10 a.m. And then the last thing here, just to give you a sense, I put some of the questions in there, but you'll all be receiving an ebook. Again, from after all our webinars, we have ebooks. We have 6 different ebooks about Fabric. In this case, the machine learning with Fabric, you'll either getting it from Nick or Abe. So really appreciate everybody's time, and the presenters, great job. And we look forward to seeing you in the next webinar. Thank you so much. Have a great day.
Thank you.
Okay,
Thank you.
bye-bye. Bye-bye.
Thank you.